This is test number 1. I'm going to go over all the answers with you. That way you'll be ready to retake the test. So to start out, we have our graph here. It says, is the exponent of the highest degree term even or odd? So if you remember that if the highest degree term is even, the ends of the graph both point the same way. They can either point up or they can both point down. If things are odd, that means one side is pointing up and one side is pointing down. So since these are pointing different directions, the exponent of the highest degree term is going to be odd. Now we just need to determine whether the coefficient of the highest degree term is positive or negative. So for this, you look at the right side of the graph. You always are looking at the right side. So if the right side is pointing up, then it is positive. And in this case, it is pointing up, so the answer is positive, but I'm just going to write it out just so that way you know. If the right side of the graph was pointing down, it would be negative. This case, the answer was positive because the right side of the graph is pointing up. So this one is asking for very large values of x, such as when x is going to infinity. Which expression is greater than 25x to the 6? So all you're really looking at is the exponent here. Things will be greater if they have an exponent that is bigger than 6. So they will be greater if the exponent is greater than the number that they give you here. So in this case, we have x to the 7th. 7 is greater than 6, so this one is going to be greater than this expression. This one has an exponent of 2. 2 is not bigger than 6, so we are not selecting this one. 25 to the x power, that one is greater than x to the 6, because if you think about it, x can be any number. Can you think of a number bigger than 6? Yes. So in this case, 25 to the x power is greater than this expression. So it says if f of x is x squared plus 4x minus 7, and we have g of x, which is 2x minus 6, we are going to add them in part A and then multiply them in part B. So when you add them, I'm just going to write it out. I have the f equation, so x squared plus 4x minus 7, and I'm adding that to the g equation, 2x minus 6. And all this is combining like terms. So I have an x squared. I have no other x squares, so that stays by itself. I have a 4x plus a 2x. These are like terms since they both have the x. So 2 plus 4 is 6x. And then I have just the numbers without the x's, so -7 plus -6 is -13. So this is my answer. Now when I multiply, I'm going to write out my f equation. And I'm going to multiply that by the g equation. Now a lot of people prefer to put the g equation first because it only has 2 terms in it. So I'm going to put 2x minus 6 first, and then I'm going to put the f equation. It doesn't matter which way you do it, but I think we came to the conclusion in our class that we liked it better with the 2 terms first. So now we're going to take this 2x and we're going to multiply it by each term in the f equation. So we're going to do 2x times x squared. That is 2x cubed. 2x times 4x. 2 times 4 is 8. X times x is x squared. Then 2x times -7. 2 times -7 is -14. And then we just have the x here. Now we're going to take the -6 and multiply it by each term in the f equation. So -6 times x squared is -6x squared. -6 times 4x is -24x. And -6 times -7 is +42. Now I just need to combine like terms. So start with the biggest exponent. I have 2x cubed. There are no other x cubes, so I'm just going to rewrite it. Then I'm going to move on to the x squares. I have 8x squared minus 6x squared. So 8 minus 6 is 2. And then you have your x squares. I have -14x and -24x. -14 minus 24, that's -38 with just one x at the end. And then finally, I just have the ones that are a number without any x's, so I'm just going to have +42. So we're done with the first page. The next page, it says, look at the graph of the polynomial function, and we're going to describe the key features. So as x goes to infinity, we need to decide if this is the left or the right side of the graph. Well, the left side of the graph has negative numbers, so this side is -infinity. This side is +infinity. So when the x-axis goes to infinity, we're looking at the right side of the graph. What's happening on the right side of the graph? Well, the graph is pointing up. So up is also +infinity. Now the x-intercepts, that's where it crosses the x-axis. It crosses the x-axis at -2 and at 1. I don't really like the comma there, so I'm going to write and. -2 and 1. Now we need to talk about where f of x is decreasing. Decreasing is when it's going down, okay? So if I'm following my graph here, and get a highlighter, I start on the left side of the graph, I follow the graph, it's going up, 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 and then we reach the top. When you get to a top section, then it starts decreasing. So this section right here, it's decreasing till it gets to 1, and then it changes to going up, up, up again. So we are going to say that it's decreasing, and you use the x values from -1 to +1. Then it's asking about the relative maximum. A maximum is a highest point, so where that hill is, where the top of the hill is, and that is at -1, 4. Page 3. We talked about even and odd functions. Even functions, we talked about how you can fold it in half like a butterfly. Odd functions, we talked about, oh, if you spin your paper, it looks the same. This is an even function. Now an even function is the folding in half like a butterfly, so the points are symmetrical about the y-axis. So I have my y-axis here. I'm just going to reflect the points across the y-axis. So this point is on the y-axis, so it stays the same. This point would reflect over the y-axis, so it was at 1, 1. Now it's at -1, 1. Let me find the next point. The next point is at 2, -2. So when I reflect it, it's going to be at -2, -2. The next point that crosses at a whole number intersection is 3, -7. So that's going to reflect over to -3, -7. And you just kind of sketch a line that goes through those points. So for an even function, the x value changes sign, and the y value stays the same. So remember we had 2, -2. When I reflected it, the x value became negative and the y value stayed the same. Now for an odd function, both of the coordinates change sign. So the x value changes sign and the y value changes sign. So if I have a -9, that would change to a +9. If I have a +5, it changes to a -5. Then we have the last page of the test here. This one is the f function, and then we have the g function over here. So it says to complete the table of values for the given x values. So when x is -2, so I'm going to look where -2 is on my graph. -2 is here. The function is at +6. Okay, so I'm going to do 6. Now I'm going to look at g. At -2, the graph is at -7. So it wants me to then add f plus g. So 6 plus -7 is -1. Then you have f times g. It's the same f, the same g. So I'm going to do 6 times -7, and that is -42. I'm going to do the same thing, but I'm going to do it when x is 3. So when x is 3, the y value, right, so here's 3, the y value is at -4. For g, here's positive 3. I'm going to go to the graph, go over to the y-axis. It is also at 3. So I'm going to add the numbers together because this symbol says add. Negative 4 plus 3 is negative 1. And then this is for multiplying, so negative 4 times 3 is negative 12. It then asks, what is the degree of the polynomial if I was to multiply f times g? Now you don't need to multiply it all out, you just need to multiply the highest exponent in each of the functions. So if I look at f, the highest exponent is with an x squared, and the highest exponent in g is 2x. So I'm going to do x squared times 2x, and that gives me 2x to the third. All right. This problem is just asking for the degree, which means it just wants the exponent. So you can just write 3 there. And that wraps up the first test.